Have you ever seen packets labeled pure ghee or pure milk in the supermarket? But here's the twist, in science, these aren't really pure. So, what does pure mean in science? And how do we know if matter around us is pure or not? In this video, we'll explore mixtures, solutions, suspensions, colloids, and even the difference between elements and compounds. Let's dive in. In everyday language, pure means free from adulteration. But scientifically, a substance is pure only if all its particles are of the same kind and have the same chemical nature. For example, pure water contains only HO molecules. But milk, which we often call pure, is actually a mixture of water, fat, proteins, and vitamins. Similarly, most things around us, seawater, soil, air, are mixtures. Mixtures are made of more than one pure substance. They are of two types. Homogeneous mixtures, solutions have uniform composition. For example, salt dissolved in water. Heterogeneous mixtures do not have uniform composition. For example, oil and water or sand mixed with salt. A solution is a homogeneous mixture of two or more substances. The substance present in larger quantity is the solvent, and the one dissolved is the solute. For example, in sugar water, sugar is the solute and water is the solvent. Properties of solutions include: particles are too small to be seen. They do not scatter light. They cannot be separated by filtration. That's why when light passes through salt water, we cannot see its path. Solutions can be dilute, concentrated, or saturated. A saturated solution is one where no more solute can dissolve at a given temperature. We can express concentration in terms of mass by mass percentage, mass by volume percentage, or volume by volume percentage. A suspension is a heterogeneous mixture where particles are visible and may settle down. For example, chalk in water or muddy water. Suspensions have these properties. Particles can be seen with naked eyes. They scatter light, Tyndall effect. They are unstable and can be filtered out. A colloid is a special type of mixture where particle size is between solutions and suspensions. Though colloids look homogeneous, they are actually heterogeneous. Their properties include: they scatter light, Tyndall effect. Particles don't settle down. They cannot be separated by ordinary filtration. Examples of colloids include milk, blood, and fog. Changes around us can be classified as physical or chemical. Physical changes, no new substance is formed. For example, melting ice or boiling water. Chemical changes, new substances are formed with different properties. For example, rusting of iron or burning of candle. Physical changes are usually reversible, but chemical changes are mostly irreversible. An element is a substance that cannot be broken down further by chemical means. For example, metals like copper, nonmetals like carbon, and metalloids like silicon. A compound is formed when two or more elements combine chemically in fixed proportions. For example, water, sodium chloride, carbon dioxide. The difference between mixtures and compounds is that mixtures are physical combinations with variable composition, while compounds are chemical combinations with fixed composition. Suppose you have a colorless liquid labeled as pure water. How will you confirm if it's really pure? One way is to check its boiling point. Pure water boils sharply at 100 degrees Celsius. If it boils at a different temperature, it contains impurities. So, we learned that most materials around us are mixtures. We understood the difference between solutions, suspensions, and colloids, saw how physical changes differ from chemical ones, and explored elements and compounds. If you found this explanation helpful, don't forget to like, share, and subscribe to Sharp Study for more easy explanations. See you in the next class.